Consider your morning cup of tea. The kettle boils, steam rises, you pour the water, watch the colour bloom from the tea bag, and think nothing of it. Why would you? This is the most ordinary moment imaginable, repeated billions of times daily across the planet. Unremarkable in every way. But here is what should trouble you. The water boils at 100 degrees Celsius, not because the universe particularly cares about your breakfast, but because the electromagnetic force between molecules has a particular strength. This force, one of the fundamental constants of nature, determines how electrons orbit nuclei, how atoms bond, how molecules behave. It is a number we measure but do not choose. And if that number were just 4% different in either direction, electrons would either fly free from atoms entirely or collapse into nuclei. There would be no atoms as we know them, no molecules, no water, no tea, no you. We find ourselves in a universe governed by numbers we never selected and cannot change. The strength of gravity, the mass of the electron, the charge of the proton, the speed of light. These are the fundamental constants, the settings on the cosmic machinery that determines whether anything interesting can happen at all. We take them for granted as background facts, like the colour of the sky or the wetness of water. They simply are. But here is the strange thing. They could have been otherwise. Nothing in our current understanding of physics explains why these numbers have the values they do. They are not derived from deeper principles. They are not mathematical necessities. They are simply what we measure when we examine the universe carefully. And when we look at what would happen if they were different, even slightly, we find something extraordinary. The universe would be dead. Consider gravity. It holds you to the Earth, keeps the moon in orbit, shapes galaxies across billions of light years. Gravity seems powerful, fundamental, inescapable. Yet, try this simple experiment. Take a small refrigerator magnet and use it to lift a paperclip from your desk. Congratulations. You have just witnessed a tiny magnet defeating the gravitational pull of the entire planet Earth. Gravity is weak, absurdly, mysteriously weak compared to the other fundamental forces. Electromagnetism is roughly 1036 times stronger. That's a 1 followed by 36 zeros. This disparity is so extreme that physicists call it the hierarchy problem, and it has puzzled them for decades. But here is what you should understand. Gravity's weakness is not a flaw in the cosmic design. It is why you exist. If gravity were stronger, strong enough to be comparable to electromagnetism, stars would burn through their nuclear fuel in mere millions of years rather than billions. There would be no time for planets to form, for chemistry to complexify, for evolution to sculpt life from dead matter. The patient, billion-year process that produced you requires gravity to be weak. We are made of stellar patience, and that patience requires precisely this ratio. The same pattern appears everywhere we look. The strong nuclear force binds protons and neutrons together in atomic nuclei. Increase it by just 2%, and all the hydrogen in the early universe converts to helium. No water, no organic chemistry, no life. Decrease it by 5%, and deuterium becomes unstable, halting the nuclear fusion that powers stars. The universe becomes a cold, dark soup of hydrogen forever. The electromagnetic force, which governs chemistry, sits in a narrow window, a few percent stronger, and atoms cannot form, a few percent weaker, and molecules fall apart. Every atom in your body, every carbon, every oxygen, every hydrogen exists because this number falls within an extraordinarily constrained range. You are drinking your tea in a universe balanced on a knife's edge. This is not metaphor. This is not poetry. This is physics. Measured, calculated, verified. The fundamental constants of nature appear to be tuned with extraordinary precision, and that precision permits everything you see around you. Stars, planets, chemistry, life, consciousness, T. The question that should now trouble you is simple. Why? Why do these numbers have the values they do? Why do they fall within the narrow ranges that permit complexity? We did not choose them. We cannot change them. We simply find ourselves in a universe where they happen to be exactly what life requires. Imagine a dial labeled electromagnetic force strength. You can turn it up or down. At the current setting, atoms form. Chemistry works. You exist. Turn it 4% in either direction and watch what happens. Matter, as you know it, vanishes. Now imagine dozens of such dials, each one a fundamental constant, each one set with apparent precision. Who set these dials, and why do they sit precisely where life requires? Most people never ask these questions. They assume the constants had to be what they are, that some deeper necessity fixes their values, that physics simply is this way and couldn't be otherwise. But this assumption is not established. Nothing in fundamental physics demands these particular numbers. They appear to be contingent. They could have been different. And if they could have been different, we are forced to ask, why these values? This question has troubled physicists and philosophers for decades. It goes by various names: the fine-tuning problem, the anthropic puzzle, the cosmic coincidence. Whatever you call it, the core mystery remains. The constants of nature appear precisely calibrated for life. The precision is not modest. As we shall see, it is absurd. But we are getting ahead of ourselves. Before we can appreciate just how absurd the precision is, we must measure it. We must move from qualitative strangeness to quantitative shock. As we shall see, the precision involved is not merely impressive. It is cosmic. Now we must put numbers to the strangeness. Fine-tuning is not a vague impression or a philosophical mood. It is measured, calculated, and expressed in terms that should make any reasonable person pause. We are not discussing modest precision, the kind you might find in a well-made watch or a carefully calibrated instrument. We are discussing precision that exceeds anything in human experience by factors that language struggles to convey. Consider the cosmological constant. This is perhaps the most important number in physics that you have never heard of. It determines whether the universe expands gently, allowing galaxies to form and chemistry to proceed, or whether space itself tears apart before anything interesting can happen. It is, quite literally, the difference between a cosmos and chaos. Quantum field theory, our best understanding of the microscopic world, predicts that empty space should seethe with energy. Virtual particles pop in and out of existence constantly, and their collective contribution should produce an enormous energy density filling all of space. How enormous? Roughly 10 mobbers 120 times larger than what we actually observe. Let that number sink in. 10, 120. That is a 1, followed by 120 zeros. This is not a small discrepancy. This is the largest gap between theoretical prediction and experimental observation in the history of physics. Something is cancelling this enormous predicted value almost perfectly, leaving behind the tiny residual we actually measure. The precision required is like tuning a dial to 120 decimal places. To grasp what this means, consider a thought experiment. Imagine a dartboard. Not an ordinary dartboard, a cosmic one. The bullseye represents the narrow range of cosmological constant values that permit galaxies, stars, and life. This bullseye is the size of a single atom. The dartboard itself extends to the edge of the observable universe, roughly 93 billion light-years across. Now throw a dart, blindfolded. The probability of hitting that atomic bullseye is the probability of getting the cosmological constant right by chance alone. This is the precision we are discussing. This is not a metaphor chosen for dramatic effect. This is mathematics derived from measured physics. Does it feel like luck to you? The cosmological constant is perhaps the most extreme example, but it is not alone. Consider the hierarchy problem, the mysterious weakness of gravity we encountered in Chapter 1. Why is gravity 1036 times weaker than electromagnetism? Physics offers no explanation. The ratio simply is what it is. But if it were significantly different, stars would burn too fast, or not at all. The universe would be sterile. Then there is the strong nuclear force. Stars forge the heavier elements, carbon, oxygen, nitrogen, everything your body is made of, through nuclear fusion. This process is extraordinarily sensitive to the strong force's strength. In the 1950s, the astronomer Fred Hoyle made a remarkable prediction. He realized that stars could only produce significant quantities of carbon if a specific nuclear resonance existed in the carbon-12 nucleus, a resonance that had never been observed. The resonance had to be there, Hoyle argued, because we are here, and we are made of carbon. The resonance was subsequently discovered exactly where Hoyle predicted. This is not design inference from ignorance. This is prediction from physics. Hoyle, incidentally, was an atheist, yet he was so struck by this apparent fine-tuning that he famously remarked, "The universe looked like a put-up job," as if someone had monkeyed with the physics. He did not conclude from this that there was a designer, but he was honest enough to acknowledge the strangeness. The list continues. The ratio of proton mass to electron mass, the strength of the weak nuclear force, the number of spatial dimensions, each constant sits within a narrow window that permits complexity. Change any one of them significantly, and the universe becomes inhospitable, not merely to human life, but to any conceivable chemistry-based life. We find ourselves not merely in an unusual universe, but in an extraordinarily unusual one. The probability of randomly selecting our constants from all possible values is, by some estimates, less than 1 in 10,500, a number so large that astronomical doesn't begin to describe it. Some dismiss this as exaggeration. It is not. The calculations are available in the physics literature. The constraints are derived from measured constants and well-understood physics. This is not speculation or philosophy. This is what the equations say. Others assume future physics will explain why the constants must be what they are, that some deeper theory will show these values are necessary, not contingent. Perhaps, but nothing in current physics points in this direction. The more we understand fundamental physics, the more arbitrary the constants appear. String theory, our most ambitious attempt at a unified theory, suggests not one unique set of constants, but roughly 10⁵00 different possible sets, each corresponding to a different way the theory's extra dimensions could be configured. Rather than reducing fine-tuning to necessity, our best theories seem to be multiplying the possibilities. We are left with a question that will not go away. The constants are not derived from deeper principles. They could have been different. Yet they happen to fall within the extraordinarily narrow ranges that permit life. The obvious inference is design. Someone, or something, set these values deliberately. The universe was calibrated for inhabitants. The precision demands a calibrator. This inference feels powerful because it mirrors how we think about human artifacts. We find a watch on a beach and infer a watchmaker. We find code in a cell and infer a programmer. We find fine-tuning in the cosmos and infer, what? A cosmos maker. The design argument from fine-tuning is not primitive superstition. It is not ancient mythology dressed in modern vocabulary. It is, in fact, the most sophisticated argument for a creator ever devised. It does not rely on sacred texts or mystical experiences. It relies on physics, on measurement, on mathematics, and it deserves to be taken seriously. Before we can see why it fails, we must understand why it seems to succeed. We must build the argument carefully, respect its logic, feel its force. Only then will we be able to see where it breaks. As we shall see, it breaks, but subtly, instructively, and the lesson it teaches transforms how we understand our place in existence. The precision is real. The narrowness is measured. The design argument beckons. If the constants are so perfectly calibrated, who calibrated them? Let us be honest about the power of this argument. The design inference from fine-tuning is not the refuge of those who don't understand science. It is an argument that takes science seriously, more seriously perhaps than many of its critics. It begins with measured physics, proceeds through valid reasoning, and arrives at a conclusion that feels almost inescapable. We should not dismiss it too quickly. To do so would be intellectually dishonest. Consider how the argument works. When we find a watch on a beach, we infer a watchmaker. Why? Because the watch exhibits complexity and precision that could not have arisen by chance alone. The arrangement of gears, springs, and hands serves a purpose, telling time. This functional complexity points to intention. Now consider the universe. The fundamental constants exhibit precision far beyond any watch. The functional complexity, permitting stars, chemistry, life, far exceeds telling time. If the watch demands a watchmaker, doesn't the universe demand a universe maker? This is not a foolish question. It is the application of perfectly ordinary reasoning to extraordinary circumstances. We are pattern-recognizing creatures. We evolved to detect intention in our environment, to distinguish the random rustle of leaves from the deliberate footstep of a predator. This capacity serves us well. When we see a cake, we infer a baker. When we see a building, we infer an architect. When we see code, we infer a coder. The fine-tuning argument asks us to apply this same reasoning cosmically. The universe exhibits apparent design. The precision is documented. The functionality is evident. Why should cosmic complexity be treated differently from terrestrial complexity? Moreover, unlike older arguments for design, this one is grounded in modern physics. The classic argument from design pointed to biological complexity, the eye, the wing, the intricate machinery of cells. Darwin's theory of natural selection explained how such complexity could arise without intention through the blind process of variation and selection over vast timescales. Biological design was dissolved into algorithm, but the fine-tuning argument is different. Natural selection cannot explain why the constants have life-permitting values. Evolution operates given the constants, it does not set them. The fine-tuning of physics lies beneath biology, immune to biological explanation. If the constants were wrong, there would be no biology to explain. This is what gives the argument its bite. It does not depend on gaps in biological knowledge. It depends on measured physics. The numbers are real. The precision is calculated. The narrowness of the life-permitting range is derived, not assumed. For all these reasons, a reasonable person might find the design inference compelling, perhaps even obvious. And yet, The argument contains a subtle flaw, subtle enough that you might miss it if you move too quickly. To see the flaw, we must distinguish between two questions that the argument conflates. Question 1. Why do the fundamental constants have the values they do? Question 2. Why do we observe a universe compatible with our existence? These look like the same question. They are not. Question 1 is genuinely puzzling. Physics offers no explanation for why the constants are what they are. They appear to be contingent. They could have been different. This is a real mystery, and the design inference is one possible response to it. But question 2 is different. Question 2, upon reflection, answers itself. Consider, could we ever observe a universe incompatible with observers? Could we ever find ourselves in a cosmos where the constants preclude life? The question is self-refuting. If the constants didn't permit observers, there would be no observers to ask the question. This is not a trivial point. It means that our observation of a life-permitting universe tells us nothing about whether the universe was designed. We would observe such a universe regardless of how it came to have those constants, because we couldn't observe any other kind. Think of it this way. A lottery winner might look at her winning ticket and marvel at her incredible luck. The odds were millions to 1 against her. Surely something special happened. But no, someone had to win, and she happens to be the one asking the question. Her observation of winning is entirely expected, given that she is the one doing the observing. Losers don't do interviews. The fine-tuning argument makes a similar error. It looks at our observation of a life-permitting universe and infers that the universe was calibrated for us. But our observation is guaranteed regardless of how the universe came to be the way it is. We are the lottery winners marveling at our ticket, not realizing that only winners get to marvel. This is the crack in the argument's foundation. It confuses two very different questions. Why the constants are what they are, genuinely puzzling, and why we observe what we observe, self-answering. Once you see this distinction, the design argument loses much of its force. It no longer seems like the obvious inference. It seems like a subtle mistake. The mistake of thinking our observation of life-permitting constants is surprising, when in fact it's the only observation we could ever make. But we are not finished. The design argument fails, but its failure leaves us with a problem. If not design, then what? We have explained why our observation of fine-tuning is not surprising, but we have not explained why there is a fine-tuned universe to observe in the first place. If our universe is the only universe, the mystery remains. The constants are still contingent. They still could have been different. And we still need to explain why, out of all possible values, they happen to permit life. We have shown that the design argument fails. But we have not provided an alternative. As we shall see, physics provides one, and it is rather more interesting than a cosmic watchmaker. Imagine you are a fish. You have spent your entire life in water. You swim through it, breathe it, take its existence entirely for granted. Water is simply the medium of existence, as unremarkable to you as air is to a surface dweller. One day, you become philosophically inclined. You begin to notice things about your environment that you had previously ignored. The density of water allows you to float neutrally, neither sinking nor rising. Its temperature falls within the narrow range your metabolism requires. Its chemical composition provides oxygen through your gills. How fortunate, you think. What incredible luck that I find myself in this medium so perfectly suited to my needs. Out of all the possible environments, sand, rock, vacuum, Air. I happen to inhabit the one that supports my existence. The odds against this seem astronomical. But then a thought occurs to you. If you are a particularly clever fish, could you have found yourself in sand? Could you have existed in a vacuum, marvelling at its peculiar properties? Of course not. A fish contemplating sand would be a contradiction. A fish exists only in environments that support fish. Your observation of water tells you nothing about whether water was designed for you. It tells you only where fish must be. We are in precisely the same situation. Only the water is the universe itself. This insight has a name, the anthropic principle. Stated carefully, it observes that any universe containing observers will, by definition, be observed, and will possess properties compatible with observers. This is not mystical wisdom. It is not philosophical sleight of hand. It is logic. Observers observe observable universes. Full stop. The anthropic principle reframes the fine-tuning puzzle entirely. The question, why do we observe a fine-tuned universe, has the same logical structure as why does a fish observe water? The question answers itself once you see the selection effect at work. Douglas Adams, the science fiction writer, expressed this with characteristic wit. A puddle, he suggested, might look at the hole it occupies and think, "This is an interesting hole I find myself in. Fits me rather neatly, doesn't it? In fact, it fits me staggeringly well. It must have been made to have me in it." But of course the puddle is wrong. The hole was not made for the puddle. The puddle was shaped by the hole. The fit is perfect, not because of design, but because of accommodation. We are cosmic puddles, shaped by the universe we observe, marvelling at how well we fit. This insight dissolves the apparent force of the fine-tuning argument. The design inference assumed that our observation of life-permitting constants was improbable, that it demanded explanation in terms of intention. But our observation is not improbable at all. Given that we exist, it is the only observation we could make. The constants had to appear fine-tuned to us, whether or not anyone tuned them. Consider a thought experiment to make this vivid. Imagine a vast casino containing infinitely many slot machines. Each machine is programmed with different odds. Most pay nothing. Some pay modest amounts. A vanishingly rare few hit massive jackpots. Now imagine that the jackpots are not merely monetary, but existential. Each jackpot creates a conscious being who immediately asks, "Why was this machine set to reward me?" The answer, of course, is that the machine was not set for them. The conscious being exists only where jackpots happen. They could not ask the question from a machine that never paid out. Their existence selects for the observation of winning. We are those jackpot beings. The universe did not produce us intentionally. We, aware improbabilities, became conscious. But wait, a careful viewer might object at this point. The anthropic principle explains why we observe what we observe. But it doesn't explain why there is a fine-tuned universe to observe in the first place. The objection is correct, and it reveals the limits of the anthropic principle taken alone. If our universe is the only universe and its constants are contingent, could have been, different, then we are back to the original mystery. Why, out of all the possible values, do the constants happen to permit life? The anthropic principle tells us we couldn't observe otherwise, but it doesn't tell us why there is anything to observe. To complete the picture, we need something more. We need the constants to not be chosen, tuned, or designed, but also not be miraculous coincidences. We need a context in which life-permitting values are rare, but not uniquely improbable. We need, in other words, other universes. And remarkably, Physics provides them, not as speculation, not as philosophy, not as theology in disguise, as implication. The multiverse is not a metaphysical fantasy invented by scientists who want to avoid God. This is important to understand because the idea often gets presented as if it were motivated reasoning, a desperate attempt to escape the design inference by multiplying universes until fine-tuning becomes statistically unremarkable. If this were the history of the idea, the suspicion would be warranted. But it is not the history. The multiverse emerged from our best-tested physical theories, developed to solve entirely different problems. It was not needed to explain fine-tuning. It was discovered while we were trying to understand why the universe is flat, why it is uniform, and why distant regions of space seem to be in thermal equilibrium when there hasn't been time for them to exchange signals. These are the flatness problem, the smoothness problem, and the horizon problem. They troubled cosmologists for decades. In the early 1980s, a theory called inflation was developed to solve them. Inflation proposes that the very early universe underwent a brief period of exponentially rapid expansion, a cosmic growth spurt that smoothed out any initial wrinkles and flattened space to the remarkable degree we observe. Inflation solved the problems it was designed to solve. Its predictions, the spectrum of fluctuations in the cosmic microwave background radiation, the statistical distribution of galaxies, the flatness of space, have been confirmed with extraordinary precision. It is one of the most successful theories in modern cosmology. But inflation has an interesting property. Once it starts, it tends not to stop. The physics that drives inflationary expansion also ensures that it continues eternally in most of space, even as it ends locally. Our observable universe is one region where inflation happened to stop, a bubble in a vast foam of eternally inflating space. Other bubbles form endlessly, each potentially becoming a universe in its own right. This is not speculation added to inflation. It is a generic prediction of the theory. Physicists call it eternal inflation, and it transforms the fine-tuning problem completely. Because here is the key insight. Different bubbles need not have the same fundamental constants. String theory, our most ambitious attempt to unify gravity with the other forces, suggests that the constants of nature are not fixed once and for all. They depend on how the theory's extra dimensions are curled up and configured. And string theory's mathematics allows for roughly 10,500 different configurations, each corresponding to a different set of fundamental constants. This vast space of possibilities is called the string theory landscape. If eternal inflation is true, and the string landscape is real, then all these possibilities are realized somewhere. The multiverse contains universes with every conceivable combination of constants. Most of these universes are sterile. The constants don't permit stable atoms, or don't allow chemistry, or don't support stars. Life cannot arise in them. No one observes them because there is no one to observe. But a vanishingly small fraction, a fraction so small that it looks like zero from most mathematical perspectives, have constants that permit complexity. Stars form, chemistry proceeds, evolution operates, conscious beings eventually emerge and ask, why does this universe have these particular constants? The answer is now obvious, because you couldn't ask the question anywhere else. The question, why this universe, becomes, why would you expect to be anywhere else? The improbability doesn't disappear. It simply distributes across a vast space of possibilities, most of which are empty. We are where life is possible, observing what life can observe. This is not design, it is selection. Not selection by anyone, selection by existence itself. Consider the analogy more carefully. Suppose you shuffle a deck of cards and deal a specific hand. The 7 of hearts, the Queen of spades, the 3 of clubs, the Ace of diamonds, and the 9 of hearts. The probability of that exact hand was roughly 1 in 2.5 million. Improbable, remarkable. Surely someone must have arranged it, but of course no one arranged it. The hand had to be something, and every possible hand is equally improbable. The improbability is real, but unremarkable because all outcomes were equally unlikely. The multiverse makes fine-tuning work the same way. Every set of constants is improbable, but they all exist somewhere in the landscape. We observe our particular set, not because it was chosen, but because it permits observers. The shift in perspective is profound. We move from, why does the universe have these constants, to, where in the landscape of possibilities do we find ourselves? The first question seems to demand a cosmic tuner. The second question answers itself. We find ourselves where we could exist. Some people find this conclusion disappointing. If the universe wasn't made for us, doesn't that diminish our significance? If we are statistical flukes rather than intended creations, doesn't life lose its meaning? We shall address these concerns fully. But for now, notice what the multiverse doesn't say. It doesn't say we are unimportant. It doesn't say life is meaningless. It says only that our existence does not require a designer, that the improbability of our constants is explained by selection, not intention. Whether this is disappointing depends on what you were hoping for. If you were hoping for cosmic validation, for the universe to confirm that you are the point of existence, then yes, the multiverse delivers a different message. But if you were hoping for truth, for an accurate understanding of your situation in existence, then the multiverse offers something remarkable. We are not the purpose of creation. We are its self-awareness, and that, as we shall see, may be the more extraordinary fate. The fine-tuning puzzle is dissolving. The constants are not tuned by anyone. They vary across the multiverse landscape, and we observe the values we do because we couldn't observe any others. Statistics replaces intention. Selection replaces design. The cosmic watchmaker was never needed, but objections remain, serious ones. Can the multiverse actually be tested? Isn't invoking unobservable universes just trading one mystery for another? And what about meaning? If we're accidents in an indifferent cosmos, does anything we do matter? These questions deserve serious answers. As we shall see, they have them. We must now face the most serious objection. If we cannot observe other universes, isn't the multiverse just speculation dressed as science? Isn't this the sort of move that gives physics a bad name, inventing invisible entities to explain away inconvenient questions? How is "there are countless unobservable universes" any better than a designer did it? The objection deserves serious engagement. It is not foolish. It reflects a genuine concern about the boundaries of science and the danger of unfalsifiable claims. But it is, ultimately, mistaken. To see why, we need to understand how science actually works, as opposed to how it is sometimes caricatured in popular accounts. The objection assumes that science requires direct observation of the entities it posits. It does not. Science requires theories that make testable predictions. The entities themselves need not be directly observable, provided they are implications of theories that are tested. Consider atoms. For most of history, atoms were philosophical speculation, invisible, indivisible particles that some ancient thinkers believed constituted matter. By the 19th century, Atoms had become a useful scientific hypothesis, explaining chemical reactions and the behavior of gases. But they remained invisible. No one had seen an atom. Many prominent scientists doubted they existed at all. What changed? Not direct observation. That came much later. What changed was that atomic theory made predictions. It predicted the precise ratios in which elements combine. It predicted the statistical behavior of gases. It predicted phenomena like Brownian motion, the jittering of pollen grains in water, that Einstein showed could only be explained by atomic collisions. Atoms were accepted not because we could see them, but because denying them required rejecting successful theories. The same logic applies to the multiverse. Inflationary cosmology makes testable predictions. The spectrum of temperature fluctuations in the cosmic microwave background radiation, the statistical distribution of galaxies across the sky, the flatness of space. These predictions have been confirmed with remarkable precision by satellites like COBE, WMAP, and Planck. If inflation is true, and the evidence strongly suggests it is, then eternal inflation likely follows from the same physics. And if eternal inflation is true, the multiverse is its natural consequence. We do not observe other universes directly, just as we did not observe atoms directly, but we observe the predictions of theories that imply their existence. Consider a detective investigating a crime. She arrives at a scene and finds a warm stove, fresh coffee, and a recently opened newspaper. She concludes that someone was home shortly before. She did not see the person directly. She inferred their existence from evidence. Now imagine a different detective, one who refuses to consider any suspect she cannot personally observe. She will solve very few crimes. Science works like the first detective. Inference from evidence is not second-class reasoning. It is how we extend our understanding beyond the limits of direct perception. The interior of the sun, the moment of the Big Bang, the interior of black holes, events beyond the cosmological horizon. All of these are forever inaccessible to direct observation, yet we have excellent reasons to believe our theories describe them accurately. The multiverse asks nothing more than we already grant to established physics. But there is a deeper point here. The objection treats unfalsifiable as automatically disqualifying, as if any theory that cannot be directly tested is unscientific by definition. This view, sometimes called naive falsificationism, was popular in the mid-20th century, but has been largely abandoned by philosophers of science. The reason is simple. No interesting scientific theory is directly falsifiable in isolation. Theories come bundled with auxiliary assumptions about measurement, background conditions, and the reliability of instruments. When a prediction fails, it might be the theory that's wrong, or it might be one of the auxiliary assumptions. Science is not a simple matter of making predictions and checking them off. What science actually does is inference to the best explanation. We accept theories that explain the evidence better than their competitors, that are simpler, more unified, more predictive, more consistent with what we already know. The multiverse is such an inference. It emerges from our best confirmed cosmological theory. It explains fine-tuning without invoking entities beyond physics. It is parsimonious in the ways that matter. Compare the alternatives. Without the multiverse, we must explain fine-tuning through one of three options: a designer, necessity, or luck. Design invokes an entity beyond physics, a cosmic tuner whose existence and nature are unexplained. This doesn't solve the problem. It relocates it. Why does the designer exist? Why does it want life-permitting constants? We have traded one mystery for another, and the new mystery is arguably deeper. Necessity would be lovely. If the constants had to be what they are, fine-tuning would dissolve into mathematical inevitability. But nothing in current physics supports this hope. The more we understand fundamental physics, the more arbitrary the constants appear. String theory doesn't reduce possibilities to 1. It expands them to 10 mod 500. Luck strains credulity when the numbers involved are as extreme as we've discussed. Accepting 10 120-fold precision as coincidence is not impossible, but it is the sort of coincidence that demands explanation. The multiverse offers a fourth option: selection. The constants vary across a vast landscape of possibilities. We observe life-permitting values not because they were chosen, but because we couldn't observe any others. No designer needed, no impossible luck required, just statistics operating across sufficient variety. You are told that a coin landed heads 1 billion times in a row. What do you conclude? Option 1. Incredible luck. Option 2. The coin was designed to land heads. Option 3. There were vastly many coin flips, and you're only hearing about this particular sequence. Option 3 is the multiverse solution. It requires no special pleading. It requires only that more exists than what we happen to observe. The objection that the multiverse is just speculation fails because it misunderstands how science works. We do not observe other universes, but we observe the predictions of theories that imply them. We accept atoms, black hole interiors, and events beyond our horizon on the same basis. Thus, epistemic ground is solid. The intellectual objection is met. But another objection remains, and it is not intellectual at all. It is emotional. If we are accidents in an indifferent multiverse, what happens to meaning? This question haunts the fine-tuning discussion in ways that the technical objections never do. People can accept that the multiverse is scientifically respectable. They can follow the logic from inflation to eternal inflation to the landscape of possibilities. But something resists. Something feels wrong. The fear is insignificance. If we are statistical flukes rather than intended creations, does life have meaning? If the universe wasn't made for us, are we just flotsam in the cosmic foam, brief patterns of complexity that arose by chance and will dissolve back into chaos? The fear is understandable, but it is also, I believe, mistaken. Let us examine it carefully. The assumption behind the fear is that meaning requires external validation, that our lives have significance only if the cosmos was designed to produce us, only if some greater intelligence intended our existence. Without that intention, we are mere accidents, and accidents cannot be meaningful. But consider this. Why should external intention be the source of meaning? Think of two artists. The first inherits a masterpiece from a famous painter. She's told it is important. Critics confirm its significance. Museums want to display it. The painting's meaning is, in a sense, given to her, conferred by external authority. The second artist creates a masterpiece herself. No one tells her it is important. She decides it is. She invests it with significance through the act of creation. The painting's meaning is not given, it is made. Whose relationship with their work is richer? Whose meaning is more secure? The multiverse tells us we are the second artist. The significance of our existence was not handed to us by a cosmic designer. We are making it ourselves, moment by moment, through our choices, our relationships, our creations, our understanding. This is not worse than having meaning assigned. It is better. Borrowed significance can be revoked. Created significance belongs to us permanently. There is something curiously narcissistic about the demand for cosmic importance. We looked at a vast universe, billions of galaxies, each containing billions of stars, most of them far older and larger than our sun, and concluded that the point of it all was us. We are, after all, the species that named our planet Earth, as if it were the ground and everything else was sky. We put ourselves at the center of creation because that is what we do. But the history of science is largely the history of demotion. The Earth is not the center of the solar system. The Sun is. The Sun is not the center of the galaxy. It is an ordinary star in an ordinary arm of an ordinary spiral. Our galaxy is not special. It is one of hundreds of billions in the observable universe. The observable universe may not be all there is. It may be one bubble in an infinite foam. Each demotion felt like loss when it occurred. Copernicus displaced us from the center of the cosmos. Darwin revealed we were not specially created, but evolved from earlier forms. Freud suggested we are not even masters of our own minds. Each insight was resisted, often violently. Each was eventually accepted, and with acceptance came not diminishment, but understanding. The multiverse is the next step in this progression. We are not the purpose of creation. We are one of its countless expressions, existing where the constants happen to permit existence. This is not a fall from grace. It is a clarification of our actual situation. And notice what does not change. Two people wake on an ordinary Tuesday morning. One believes the universe was made for beings like her. One knows she is a statistical fluctuation in an indifferent multiverse. Both drink coffee. Both go to work. Both love their families. Both feel joy and sorrow, hope and despair. Both find meaning in their projects, their relationships, their moments of understanding. The felt experience of meaning is identical. Only the metaphysics differs. This is because meaning does not actually derive from cosmic purpose. It never did. Meaning derives from relationships, from achievements, from experiences, from understanding, from love. None of these require the universe to have been designed for you. You loved before you asked metaphysical questions. You will love after you resolve them. The meaning was always yours. The fear of insignificance mistakes the source of significance. We never needed cosmic validation. We just thought we did. Discovering that we don't is not loss. It is liberation. There is something more I want to say here, and it requires care. The multiverse does not merely fail to diminish us. In a certain sense, it elevates us. A designed universe would be impressive in the way a cathedral is impressive. Oh, grand structure built by a greater intelligence for a purpose we might never fully understand. We would be residents in someone else's creation, beneficiaries of a gift we didn't earn. But an accidental universe that produced creatures capable of understanding their own accidental origins. That is impressive in a different way. It is impressive in the way a child who teaches herself to read is impressive, or a species that figured out the laws of physics is impressive. The achievement belongs to us. No one handed it to us. We are not significant because the cosmos was designed around us. We are significant because we are the cosmos achieving self-awareness. Atoms arrange themselves into creatures capable of asking why atoms arrange. Matter contemplates matter. The universe, through us, understands itself. That is a harder accomplishment than being designed, and it carries a greater dignity. The meaning we make is not inferior to meaning that could have been given. The understanding we achieve is not less valuable than understanding that could have been revealed. If anything, what we have is better, because it is ours. The emotional objection dissolves. Meaning was never at stake. What was at stake was cosmic narcissism, the assumption that the universe owed us importance. It didn't. It doesn't. Our importance is self-generated, and no scientific discovery can take it away. We have answered the objections, intellectual and emotional alike. The multiverse is scientifically grounded. It does not diminish our significance. It does not destroy meaning. But we are not finished. Understanding, fine-tuning intellectually is not the same as feeling its implications. We must return to where we began, to morning tea and boiling water, and see it all anew. Let us return to where we started. The kettle boils, steam rises, you pour the water, watch the colour bloom, and raise the cup to your lips. The most ordinary moment imaginable. But everything has changed. You understand now that the water boils at 100 degrees Celsius because the electromagnetic force has a particular strength, a strength that sits within an extraordinarily narrow range, permitting atoms, molecules, and chemistry. You understand that the cup exists because the strong nuclear force falls within the window, allowing carbon, silicon, and the other elements to form in stellar cores. You understand that your hand lifts the cup because gravity is weak enough for complex structures to persist, for brains to evolve, for intention to emerge. You understand that none of this was guaranteed. The morning tea that once seemed mundane now reveals itself as a statement about fundamental physics. Every sip is the cosmic lottery paying out. Every ordinary moment is extraordinary physics in action, hiding in plain sight. This is not poetic exaggeration. This is what your morning actually is. The distance between cosmic physics and breakfast has collapsed because there never was a distance. Physics is not something that happens out there in distant galaxies and particle accelerators. Physics is what happens when you pour water from a kettle. It is what happens when light enters your eye. It is what happens when neurons fire in the pattern you call thought. The constants are not abstract numbers in textbooks. They are here, now, in this room, making everything possible. Consider your minor frustrations. The toast burns, the traffic delays you, the meeting runs long. These occur against a backdrop of cosmic improbability so extreme that frustration seems almost comically misplaced. You are a temporary arrangement of atoms that happens to be capable of experiencing annoyance. Let that sink in. Atoms, the same kind of atoms that form rocks and rivers and empty space, have somehow arranged themselves into a configuration that gets irritated when the Wi-Fi is slow. This arrangement required stars to burn for billions of years, forging the heavy elements that would eventually become you. It required a planet to form at the right distance from the right kind of star, with the right kind of moon to stabilize its axis. It required chemistry to complexify into self-replicating molecules, and those molecules to evolve over billions of years into creatures with nervous systems sophisticated enough to experience dissatisfaction with minor inconveniences. And you are annoyed because the coffee is too hot. There is something absurd about this, wonderfully, gloriously absurd. The gap between what we are and how we experience ourselves is so vast that ordinary life becomes surreal once you see it clearly. We are the universe experiencing frustration with itself. We are cosmic improbability complaining about being put on hold. I do not mean that frustration is wrong or that ordinary concerns are trivial. They are not trivial to you, and you are what matters. But the backdrop, the sheer improbability of there being a you to have concerns, that backdrop transforms everything. Nothing was guaranteed. Not atoms, not stars, not planets, not chemistry, not life, not consciousness, not you. Each step in the chain required specific constants to fall within narrow ranges. each step was contingent, could have been otherwise. The fact that it all came together, that the lottery paid out, that the improbable became actual, this is not something the universe owed us. It is something that happened. And we are here to notice. This perspective does not require constant awe. That would be exhausting. You cannot pour your morning tea while contemplating the fine structure constant. Or rather, you can. But it would make breakfast rather slow. The transformation I'm describing is subtler, a background awareness that nothing had to be. Yet here it is. When you next feel ordinary, remember what you actually are. You are made of atoms, forged in stars that burned for billions of years. Billions. Because gravity is weak enough to permit it. You think, with a brain that evolution shaped over aeons. Aeons possible because the strong force sits in its narrow window. You breathe oxygen produced by photosynthesis in plants, a process that works because of the specific quantum properties of chlorophyll molecules. You see, by detecting electromagnetic radiation in the narrow band your atmosphere happens to transmit, radiation emitted by a star that happens to output most of its energy in that band. Coincidence upon coincidence upon coincidence. Yet here you are. Every unremarkable moment is underlain by remarkable physics. Try this. For one day, notice 3 ordinary events: drinking water, seeing sunlight, feeling warmth, and trace each back to a fundamental constant. Water exists because electromagnetic forces permit hydrogen and oxygen to bond. Sunlight arrives because nuclear fusion in the stellar core converts mass to energy, according to E1mc2. Warmth spreads because entropy increases, the arrow of time pointing in the direction of growing disorder. Let the ordinary become a window into the fundamental. The error we make, the error we have always made, is compartmentalizing. Physics over here, in textbooks and laboratories. Daily life over there, in kitchens and commutes. But they are not separate. Physics is daily life, seen clearly. The kitchen is a physics laboratory. The commute is a physics demonstration. Your body is a physics experiment, running continuously, yielding results every second. Once you see this, you cannot unsee it. The familiar has become strange, the strange has become wonderful, and the wonderful has become ordinary. Because wonder is not an emotion reserved for rare moments of cosmic revelation. Wonder is the appropriate response to existence itself, available in every moment, hidden only by the illusion that we already understand what's happening. We have studied the universe. Now we hear its music. But one transformation remains, the deepest one. If we are accidental observers in an indifferent multiverse, what are we? What does it mean to be the cosmos looking at itself? The answer is the final revelation. Here is the final inversion. We began this journey asking why the universe is fine-tuned for life, why the constants seem set to permit our existence. The question assumed that life is what the universe is for, that the constants were calibrated to produce us. But this has it exactly backward. The universe is not fine-tuned for life. Life is fine-tuned for the universe. We are not the purpose of existence. We are how existence examines itself. We are not what the cosmos was designed to produce. We are what the cosmos accidentally became, in the rare corners where becoming was possible. And this is more remarkable than any design could be. Consider what has actually happened. The universe began, or rather, our bubble of it began, roughly 14 billion years ago, in a state of extraordinary heat and density. Over billions of years, it expanded and cooled. Hydrogen formed, then collected under gravity into stars. Stars burned and died, forging heavier elements and scattering them through space. Those elements collected again, forming planets around new stars. On at least one such planet, chemistry complexified into self-replicating molecules. Those molecules evolved, over billions more years, into creatures with nervous systems. And then something extraordinary occurred. Those nervous systems became sophisticated enough to wonder where they came from. Atoms arranged themselves into configurations capable of asking why atoms arrange. Matter started contemplating matter. The universe began to understand itself through us. This is not metaphor. This is what literally happened. You are not separate from the cosmos, looking at it from outside. You are the cosmos, looking at itself from inside. Every thought you have about the universe is the universe thinking about itself. Every question you ask is the cosmos asking itself questions. Your curiosity is physics become curious. Your wonder is chemistry become awestruck. We are the universe's self-awareness. Consider the pale blue dot, that famous image of Earth taken by Voyager 1 from beyond the orbit of Saturn. A tiny pixel in the vastness. Everything we have ever known, every human who ever lived, every triumph and tragedy, every love story and war, all contained in that barely visible speck. We were not the purpose of all that vastness. The galaxies were not arranged for our benefit. The billions of light years of mostly empty space were not designed to make us feel appropriately humble. But we were the part that looked back. We were the part that figured out how far away the camera was and what the pixel contained and why it appeared pale and blue. We were the part that understood the vastness, and in understanding it, brought the universe to consciousness of itself. The cosmos created instruments capable of measuring itself. Those instruments are us. This is what we are. Not the purpose of creation, the self-awareness of creation. Not what the universe was made for, what the universe accidentally made that can understand what the universe is. Not designed significance, achieved significance. And achieved significance is the greater dignity. Consider the alternatives. A universe designed for us would be impressive in the way a gift is impressive. We receive it, we appreciate it, but we did not earn it. A universe that accidentally produced creatures capable of understanding their own accidental origins is impressive in the way an achievement is impressive. It belongs to us. It is ours. We did it. We are not diminished by understanding that we were not designed. We are elevated by the understanding itself. The fact that atoms have arranged themselves into creatures capable of grasping their own contingency, that is the only miracle worth the name. Not design, understanding. To be an accident is to be free. To be undesigned is to be unprecedented. To exist without external purpose is to create purpose. We are not less than we thought we were. We are more, because everything we have, we made. The fine-tuning argument asked the wrong question. It asked, who set the dials? But this was never the right question. The right question is, why do we see dials at all? And the answer is that we are the dials. We are how the universe knows it has constants. We are how improbability measures itself. We are the cosmos waking up, looking around, and asking what's going on. No designer was needed. The multiverse handled the statistics. In the space of all possible worlds, we exist in one where existence is possible and could not exist anywhere else. The selection was automatic. The improbability was guaranteed by our presence. This is not disappointing. This is magnificent. We find ourselves in a universe that didn't expect us, didn't design us, doesn't care about us, and yet here we are, drinking tea, asking questions, understanding the mathematics of our own improbability. The constants that govern our existence are not tuned by any hand. They vary across a vast landscape of possibility, and we observe the values we do because we couldn't observe any others. The fine-tuning that once seemed to demand a designer is revealed as selection bias, cosmic puddles marvelling at their holes. But this is not the end of wonder. It is the beginning, because we are the universe examining itself. We are matter asking why it exists. We are the cosmos achieving something it never aimed for: consciousness, understanding, the capacity to ask questions and occasionally find answers. The fine-tuning argument asked who made the universe for us. The answer is no one. But we made ourselves capable of understanding it, and that is not nothing. Look up at the night sky tonight. Those distant lights are nuclear furnaces burning because the strong force permits it. The light reaching your eyes has travelled for years, years that elapsed because space-time has its particular geometry. The understanding you feel looking up at that vastness is the cosmos experiencing comprehension. You are not separate from what you observe. You are its self-awareness. The universe is not fine-tuned for life. Life is fine-tuned for the universe. And the fact that we can understand this, that atoms have arranged themselves into creatures capable of grasping their own contingency, is the only miracle worth the name. We are how the cosmos wakes up, and that, it turns out, is quite enough.